Hi, this is How the Earth Works Visual Verbal Presentation, Geology 1090. And today we're going to be talking about igneous rocks. Hi, I'm Susie Bailey. I'm a senior working towards my BA in General Studies, and I'll be your presenter today. I am so excited to be talking to you today about igneous rocks. They're my personal favorite type of rock. We'll be going over the birth of an igneous rock composition, igneous rock classification, igneous rock textures, and seeing what they can tell us about the geologic record. Great, let's talk about the birth of an igneous rock. The parent material for igneous rocks is molten rock called magma. Most magma consists of three materials. The liquid component is called melt, the gaseous component is called volatiles, and the solid components, if there are any, are crystals. The igneous rocks form from the cooling and hardening of molten magma. These rocks can form by the magma slowly cooling beneath the surface and are called intrusive rocks because they're in the rock, or they can cool more quickly at the surface, and these are called extrusive rocks. I like to think of extrusive because they were extruded from the volcano. Let's look at a couple of examples on this. In the diagram below, example A shows fresh lava flowing out of the volcano. And when this cools quickly, it's called an extrusive rock and it has a very fine grained or aphoretic texture to it. And here's an example on the right. You can see how the top part of this magma is cooled really quickly, so quickly that you can see, look through that crack and even see the hot lava below. The other type, extrusive, if you look down in B, um, see how it's cooled, but it hasn't quite reached the surface yet. And it's taken a long time to cool, so it forms crystals and it has a coarse grain or phaneretic texture to it. An example of that on the right is this batholith. Um, this was a part of the volcano that came up and cooled but never reached the surface. And then the hill was eroded away around it. So we can see what the shape of that big tube of lava looked like when it cooled underground. I think that's really neat. Let's talk about igneous rock composition for a moment. The mineral composition of igneous rocks can be separated into two categories: the dark colored or mafic minerals and the light colored or felsic minerals. The mafic minerals are ferromagnesian. They're rich in iron and or magnesium elements. You'll find minerals like olivine, pyroxene, and amphibole in this category. The felsic light-colored minerals are non-ferromagnesium. These ones are rich in potassium, sodium, and calcium elements. And some of the minerals you'll find in this category are quartz, muscovite, and felspar. We can use our knowledge about their mineral makeup and their texture to classify igneous rocks. For example, looking at this rock on the far left, we can see how green it is and know that this one's almost all olivine, or 90% olivine. Now we need to just look at the texture. See all these big crystals? So we know that cooled slowly underground, so it must be phaneritic. So if it's phaneritic and it contains 90% olivine, then it's going to be a pyrite. If we come over to the far right and look at this example of a phaneritic rock, you can see all the different colors of feldspar and plagioclase and case bar in there and some quartz and muscovite. So it must be a felsic rock and it's phaneritic. We've got lots of big grains in there. So we know this one's granite. The same chemical makeup in granite, if it's at an aphoretic, because it cooled rapidly, you get a rhyolite. Now that we know how to identify an igneous rock, let's see what an igneous rock can tell us about the geologic record. Looking at the composition of a rock can let us know how explosive a volcano is. If the minerals found in the lava are felsic and extrusive, it's gonna be coming from a violent volcano. Where if the minerals found in the lava are mafic and extrusive, then it probably came from a volcano much like the Hawaiian volcanoes that are um, safer volcanoes, less explosive. The texture of igneous rocks can give you an even greater look into the past. Let's explore some textures and what they can tell us. The glassy looking obsidian over here can tell us that the lava cooled quickly, like it was quenched in water. It didn't have time to form any crystals. The viscular texture of this lava formed quickly with lots of gas bubbles. So you get lots of holes in that one. The aphoretic texture formed quickly but had time to form some grains. You see that on top of the lava coming out of the volcano. The porphyritic texture was lava that started to form crystals. You can see some large crystals in there. But before they could grow many crystals, they were extruded quickly from the volcano. So you have a lot of fine grain mixed in. The pyroclastic texture is has all these little shards of different rocks in with the fine grain, and it shows a lot of destruction as a pyroclastic flow came down and broke up all these little pieces of rock and then cooled quickly around them. And then the phaneritic texture you can see in this laccolith where it cooled slowly over time and formed a bunch of nice big crystals and big grains inside that texture. Igneous rocks are so beautiful. They're also very useful. We use them in countertops and building materials. We use them for cosmetics, like the pumice stones down here on the bottom. And in the past, they even used them to make arrowheads for hunting. Thank you so much for joining me today while we explored igneous rocks. I hope you have a wonderful day. Keep searching for those rocks.